Have you ever looked at an AI and wondered how it actually thinks? It's weird, right? Sometimes they pull off these brilliant answers, and other times they just get stuck in a simple, dumb loop. Well, it turns out they were missing a key ingredient, something we humans do completely naturally. Today, we're going to dive into a framework called ReAct, and this thing might just be the key to teaching AI how to think before it acts.
So, to really get what ReAct is all about, the paper it comes from starts with a super relatable question. How do you cook a dish you've never ever made before? I mean, you don't just walk into the kitchen and start blindly chopping things, do you? No way. You've got a process.
It's kind of like this. First, you think, okay, I need to chop the onions. Then you act. You actually chop the onions. Then you observe. Cool, the onions are chopped. And that observation immediately informs your next thought. Right, now I've got to heat the pan. This whole loop, think, act, observe, think, it's this incredibly powerful synergy that's just fundamental to how we operate. And believe it or not, this is exactly what AI was missing.
So before ReAct came along, AI models pretty much took one of two different paths to solve a problem. And honestly, both were seriously flawed. You can almost picture it as an AI with two separate brains, and neither one had the whole picture. Okay, first up, let's talk about brain number one, the thinker. This approach is officially called chain of thought, and it's basically an AI that talks itself through a problem step by step. It's actually amazing at logical reasoning. But, and this is a huge but, it's all happening inside its own head. It's like a static black box, completely disconnected from what's actually going on in the real world. And that disconnect leads to its biggest, most critical flaw, what we call hallucination. Since it can't go out and check its facts, it can just make stuff up. It'll confidently invent information or make these logical leaps that are just completely, totally wrong. Then, on the complete other side of the spectrum, you've got brain number two, the doer. Now, this AI is all about action. It can interact with the outside world, using tools like a search engine or digging through a database to get information. But the doer's fatal flaw? It can't plan. It has no high-level strategy. Without that guiding thought process, it just gets stuck so easily. It'll just perform the same useless action over and over and over again because it has no idea what the bigger picture is. So here's the bottom line, right? We were stuck with these two extremes. We had one AI that could think but couldn't do anything, and another that could do things but couldn't think. It's like having a brilliant philosopher who's completely detached from reality on one hand and a mindless drone on the other. Neither one is going to get the job done. And this is exactly where ReAct enters the picture. It's such an elegant solution because it doesn't try to pick one brain over the other. Instead, it brings them together. It synergizes these two abilities into one single, powerful framework.
So how does it work? Well, ReAct prompts the language model to generate both a thought and an action for every single step. And the key word here, the most important word, is interleaved. It's not a sequence of think first, then act later. No, it's a continuous dynamic loop where the thinking informs the acting and the acting informs the thinking. So the whole process looks something like this. The model comes up with a plan, that's the thought. Then it executes one little step of that plan, that's the action. After the action, it gets new information back. We call that an observation, and here is the absolute game changer. It uses that brand new information to update its plan on the fly. See? It's that same loop. It's exactly what we do in the kitchen. Okay, so that's all the theory. Sounds good, right? But let's look at a real, concrete example straight from the research paper to see what a massive difference this actually makes in practice.
All right, check out this question. It's from a benchmark called Hotpot QA, and it's a really tricky one. To get this right, you need to do more than just find a fact. You need multiple steps of both reasoning and fact-finding. So, what happens when we give this to our thinker model? It falls flat on its face immediately. It makes a wrong assumption right out of the gate, thinking the Apple remote was for the Apple TV. Then, it just confidently hallucinates a whole list of other Apple devices. The internal logic kind of makes sense, but the whole thing is built on a foundation of, well, wrongness.
In the doer? Yeah, it doesn't do much better. It does the right first step. It performs a search. But then it gets completely confused by the results. It sees this term front row, has no idea what that means or what to do next, and it just stops. It gives up. It doesn't have the reasoning ability to create a new plan based on that new information. But ReAct? Oh, ReAct just nails it. Watch this. It starts with a thought, I need to search for the Apple remote and see what it controlled. Perfect. It takes that action, the observation comes back, and it sees that same tricky term, front row.
Now here's the magic moment. Instead of getting stuck like the doer, it has a new thought. Okay, I need to update my plan. Now I need to search for front row. And boom. That is the dynamic, adaptive reasoning we've been talking about, and it leads it straight to the correct answer. It's beautiful.
Okay, so it's clearly amazing for question answering, but what about something even harder? What about tasks that need really complex, interactive decision-making, over a whole bunch of steps?
For that, let's look at a benchmark called AlfWorld. It's basically a text-based game where the AI has to complete household chores. And the results here are, well, they're staggering. The old state-of-the-art method, a system called Butler, only managed a 37% success rate. The ACT-only model we talked about did a little better, at 45%. But ReAct blew them out of the water with a 71% success rate.
I mean, just think about that. That is an absolute improvement of 34% over the previous best. That's not just a little step up. That's a massive, massive leap in what these models can do. And it all comes from just teaching the AI to think and act at the same time.
And look, this isn't just about making AI better at playing games or answering trivia questions. The implications of what ReAct is doing are so much broader. This is a huge step forward toward AI that's not just more capable, but also way more reliable.
So, what's the big takeaway here? Well, ReAct gives us 4 massive benefits. First, it's more interpretable. We can actually read the AI's thought process and understand why it's making certain decisions. Second, it's more trustworthy because it's constantly going out and checking its facts, which helps kill those hallucinations. Third, it's way more robust. When it hits a dead end, it can actually recover and try something new. And fourth, and this one is really incredible, it's more controllable. A person can literally step in, edit one of the AI's thoughts in the middle of a task, and steer it back in the right direction.
So by bridging that huge gap between just thinking and just doing, ReAct doesn't just create a smarter AI. It creates an AI that's more grounded in reality, more transparent for us to understand, and even more collaborative. It really leaves us with a pretty fascinating question to ponder. Now that AI can reason and act in this much more human-like way, what's the next big, complex problem we can finally ask it to solve?